Hi, this is Mikhail Golovnya, Senior Scientist at Salford Systems. What I'm going to talk about in this video is the importance of prior probabilities in CART. Now first, a little bit of a background. Whenever you build a classification tree, and most specifically a binary classification tree, the case that is used most often out there by practitioners, you are really interested in separating one class from another. So let's say in fraud detection, you would be interested in separating all fraud cases from all good cases. Or in direct mail campaign, you would be interested in separating all responders from all non-responders, and so on and so forth. Now, in the ideal world, there would be a nice, perfect separation of those classes. But in the real world, classes usually tend to overlap. In other words, there is no real predetermined set of rules that would do perfect 100% separation job for the classes that we have observed in the past. And in those situations, certain compromises must be done. So when CART runs internally, as it looks for all of the best splits and making all of the internal decisions in building the tree, it is always trying to balance the misclassifications in one class versus another. And it turns out that the machinery of prior probabilities allows you to directly influence how those internal decisions are being made. And the mastery of prior probabilities essentially gives you the benefit of influencing some critical internal decisions that the tree building process does as it tries to balance the misclassifications arising on different side of the boundary, so to say. So let me go ahead and illustrate how prior probabilities work inside of CART and what are the important automation that we can do in that direction. So what I have here is a Salford predictive modeler that has just initiated a new session. And what I will illustrate here in terms of prior probabilities, I'll need a data set. So I'm going to click File, Open, go into my training folder. And I have a spam-based, publicly available data set. So what this data set has is a collection of 4,601 different emails. Each email is classified as either spam or no spam. And it's also characterized by frequencies of certain keywords, characters, and things like that. So it's a usual bag of words approach that's often utilized in text mining. I'll skip all of the details, go straight into the model. And in my case, I'm interested in building a CART tree. And the whole purpose of the modeling here is to try to build some kind of model or a tree or a set of rules that separates spam records from no spam records. So it's CART classification. If I order records in file order, I'll get my target, which is that spam, no spam situation, and all of the remaining variables will be used as potential predictors. Now, just the way this data set is constructed internally is that the target variable is coded as 0 and 1. So what I can also do here to help me with some future reports, I can go to Categorical tab, pick my target, and then use this set class names machinery to associate a value of 0 with the string label good, and the value of 1 with the string label as spam. So I've just added those two, and now in all of the output reports, whenever you encounter 0, it will be substituted with the word good, and all ones will be substituted with the word spam. So I click Done. Then I do the usual standard things. So I'll set my setting to fraction of cases selected at random. In this case, I'll use 50-50 partition. And I'll also set some limits. I'll require at least 30 records in parent nodes and 10 records in child nodes. Okay, so that's the usual setup. And let me go ahead and proceed by building a very first default CART tree. Okay, so I have my CART tree here. And the very first thing you usually do, you go look at the summary reports and confusion matrix or predictions table, depending on which version of the software you have. And here you can see that on the test 50% test sample, I have about 92-93% correct in my good emails group and about 88-89% correct in my bad emails group. And of course, at this point, I'm not interested in optimizing this accuracy. There are some better approaches like stochastic gradient boosting, etc., that might help you with that. But here, let's just see what happens as far as the single tree goes. I'm not getting perfect class separation here. And the way the default settings work is that it roughly tries to balance percent correct in each individual class. The result of it, as you can see, about 100 individual cases of good emails that were misclassified as spam, and about 98 cases in the opposite situation. Now, this particular model can also be presented in terms of ROC curve. So I'm going to put it here, and based on either both or test, you can see what actually happens with balancing one rate versus another. Now let me, at this point, try to communicate to the card to do a better job in classifying my good emails, because I don't want to have too many false positives. I don't want to lose good emails misclassified as spam. So all we need to do in order to make that kind of influence on the engine is go back to model setup, open up priors dialog, and notice by default priors are set to equal, meaning in the binary case priors are set to 0.5 and 0.5. So I'm going to override this and use priors specify option. And because 0 is my good group, 1 is my spam group, so on 0 I want to increase classification accuracy. The rule in this case is that I want to increase prior probability associated with that group and decrease prior probability associated with the opposite group. So, and now let's see what kind of influence is going to make to the cart output. So again, I went to priors tab, I chose priors specify, I increased prior probability on zeros or good emails, and I decreased prior probability on spam emails. Let's rebuild our model. Again, it happens very quickly. And now we have a new tree. And again, I go straight into the summary, confusion matrix. And it has accomplished pretty much what I was looking for, even though not in the ideal case. But now the percentage of good emails up to 93, and correct classified and correct classified for spam group is down to 86. What it also means is that now I'm having fewer false positives as far as the spam goes, and of course at the cost of increased number of false negatives. So as you can see, priors specify allows you to shift the balance of certain decisions inside of the cart engine. And again, if you look at the gains in ROC curves, they represent performance of the tree as an overall classifier using different thresholds. So we can keep that for future reference. Now let's see that what we've just demonstrated works also the opposite way. So again, I'll go into priors, and this time I will decrease prior associated with good group and increase prior associated with the spam group. So I kind of flipped those priors around, and now I click the start button again. It builds yet another tree, and when you look under summaries, the confusion matrix this time shows an increased accuracy in tracking spam group and decreased accuracy in tracking the good group. And also under gains in ROC, you get to see yet another overall summary curve. And by the way, At this point, I have 3 different models opened with all these different gains curves. There is a very easy and simple way in the GUI to superimpose all of these curves together. Just make sure that you picked all the right settings and then have all those windows open. And then go under View, Gains Charts. There's all the currently 3 opened navigators are shown here, so you can highlight them all, add them to this panel, and then click on either Lift, Gains, or ROC buttons. In this case, I'm interested in the ROC curve, so I click on that, and it opens up this summary window where all of those curves from 3 different models are superimposed on each other. So what you can see from these curves is that by changing prior probabilities, you really do fundamentally change the internal decisions that CART is making as it constructs all of those individual trees. So what have we learned so far? The prior probabilities control allows you to influence the balancing decisions that happen inside of the engine as it traces individual classes and makes internal class assignments to one class versus another. By the way, it doesn't have to be binary classification. The same machinery is equally applicable to the case of multinomial classification, but the binary case is a kind of most popular and most convenient and straightforward to demonstrate all of these individual pieces. So the bottom line, you use prior probabilities to influence internal decisions and therefore change the balance of false positive versus false negative. In the next segment, we're going to pick this idea and see what additional means of automation CART offers you in order to make it even more powerful and more productive.